Okay, let's try and clean this up a little bit. So right now we have an array list of particles, but we want to encapsulate this inside its own class called particle system. So a particle system is going to be a single object that's responsible for a collection of particles. It's going to track and maintain all of the particles. So let's start to rewrite. I think what I want to do is let's make a new class, particle system. So here it is. I am editing this with Git. So here's a particle system. So I want my particle system to have this whole array list of particles here. But because it's an attribute of a class, let's make it private. Let's make this a little smaller and we can see it. Okay. We'll need a constructor, or actually let's program by intention. Let's use it as if we'd already created it. So here I will have private particle system. I'm going to call it PS. And then here in setup, let's say PS equals new particle system. And let's do this. Let's keep it this way. We'll create all our particles the same way that we used to, only now instead of adding them to an array list, let's add them to our particle system. So we'll need an add method where we can add a particle to the particle system. Okay, so let's start implementing it. If I put my cursor there and hit Alt-Enter, I can create the method over here. And all I'll do is pass it along. I'll just say, let's take that input particle and add it to my array list of particles. Okay, so far so good. Inside draw, instead of doing this for every single particle, I want to do those steps for the entire particle system. So I want to be able to say ps.apply force gravity. And that should apply the force to all the particles in the whole particle system. I want to say ps.update, and that should update all the particles in the whole particle system. And same thing with draw. Okay, so that means we're going to need these three methods inside particle system. Let's create the method stubs first. So no bodies, just the method signatures. And we'll leave the bodies empty. Great, so now we've created those three methods. And I cut that because that's what we want to do inside each of these methods. So to apply force, I want to loop over all the particles and just apply the force, like this. We'll need to define gravity inside this class because gravity doesn't exist in this class. Oh, sorry, let's do this. We're applying the force, so actually it should look like that. Okay, that makes sense because we're passing gravity as an input here, and then that force is what we're applying to each particle. All right, let's do the update step. So for the update step, we're going to loop over everything, except we're going to tell each particle to update itself. And then in draw, same thing. We're going to loop over every particle, and we're going to tell it to draw itself. Here it says main. Let's actually make this be papplet window, the same way that it was for particles. Oops. And then we'll pass the window along to the particle. So all we're really doing in the particle system is it's telling every single particle to do the things that you would have done inside main. But what that means, that might have seemed a little silly because, you know, why bother creating an entire extra layer where we're just doing the same things? And, you know, like before we were only looping over all the particles once. Now we're looping over all the particles 3 times. That might feel like it's worse in your mind. I'll show you why in just a second. First, let's run it and just make sure that it looks the way that it should look. Okay, so that looks the way that it used to look. Now if we go back and we make it a little bit, we refactor it a little bit, it'll be easy to make several particle systems, and the code that will run them is going to be a lot shorter. So let's say we want to make it even easier. We'll create the particle system at a particular location. So instead of having the particles at 310, we'll create the whole particle system centered at 310. And then we'll loop through number of particles. Oh, you know what would be even easier? Let's do this. ps.add random. Let's just say add, let's say add particles. I'm trying to decide what to name this. So let's say add particles, and then we'll say num particles. So let's say we want those two things to do all of this. Maybe we should name it random. Should we name it random? Yeah, let's name it random. No, let's keep it this way. Okay, so let's change the constructor. Let's add this method. So in the constructor, which we haven't actually written yet, we'll say public particle system. Now we're taking two inputs, which is the xy coordinates. But now our particle system needs to know where it's centered. Or it doesn't necessarily need to know it, because we could do something like this. We could just create... Oh, well, I guess since we're not creating the particles here, yeah, we do need to know where we're centered. So you're most likely going to do something like this. You're going to say float xy, and you could do that. That could be fine. I want to continue to use p-vectors here. So I'm going to have a p-vector called position, and now I'll say position equals new p-vector xy. So now I've created the particle system to be centered at a particular location. And now let's add a method that will just automatically create particles. Oops, except I deleted my for loops. Okay, well, let's go through and do it all over again. So I'm going to have a loop here that's going to loop up to number of particles. I'll say particle p equals new particle, except this time I'm going to create it at the xy position where the particle system is centered. Let's set the velocity to be random again, the same way that we did before. And what I'm about to do is something that we should probably generalize. We can come back and do that in a later step. So I'm just going to retype it because I deleted the old one. So math.random times, what was it, 6 minus 3. And then let's do the same thing for the y velocity. So x velocity, y velocity. Great, so now running this one method will create a whole bunch of random particles centered where the particle system is centered and with those random velocities. Except I'm not actually adding them to my list yet. So this dot particles dot add p. Okay, so now I'm adding them to the list. I think that's done it. So let's run it one more time. And again, nothing's going to be changed yet. But here's why we went to all that trouble. If I wanted to create a second particle system, PS2, let's do that. So let's make one particle system at 110. Let's make a second particle system at, let's say, 410. Let's do ps2.addParticles, num particles. And then here I can do this same set of stuff for ps2. And all of a sudden, oops, I'm running in debug mode. All of a sudden, now we've got two particle systems, which looked like they were running a little bit slowly. Yes, thank you, thank you. Oh, I see. It was running a little slowly because it was trying to run it twice. Let's do it one more time. Nope, it was just slow. That's why. Okay, so now I have two particle systems. So that's the reason why you would want to encapsulate all of this inside its own class. It's because that makes it easy to flexibly control all of them at the same time, or make multiple of them, which is a thing that you might want to do. Okay, come back in the next video and we'll try and add some additional cool stuff.